r equals 1 minus 3 cos theta. Let's have a look at plotting this between 0 and 2 pi then. The thing to observe about these sorts of polar plots is that cosine only varies between 1 and minus 1. So that will dictate the values that we have for r. The maximum value will of course be 4, and the minimum value will be minus 2, depending on the value of theta that we put in. So let's start at theta equals 0 then here. So we're using polar coordinates, so I've just done an axis here to help me with the angles. So let's put theta equals 0 here. When we have cos 0 is 1. 1 minus 3 is minus 2. So here we'll have a value minus 2. That's the first value. Now as we go round, we'll go, that was a negative value, wasn't it, at 0. Now as we go round here, we're still going to get negatives, aren't we? Because cos comes down from minus 1, but it comes down slowly from minus 1. So these will still be coming around here. So it's going to come around here. Where does it cut this axis here? So what value does it have at pi over 2? If you put cos pi over 2 in, you get 0. 1 minus 0 is 1. So it's going to come right round to positive values. So when does it? What angle of theta does it equal 0? Well, if you let that equal 0, cos theta must be a third. So there'll be an angle, acute angle, probably around here somewhere, when it's going to go through 0, isn't it? So the rate, I hope you saw what I meant there. The values are going to come round, go through 0 at that when cos theta is a third, and then come back to positive then, isn't it? It's going to go like that to here. And then from when cos is 0 now. Now because in this quadrant the cosines are, this one was 0, but it's all going to turn negative. All these r's will be positive. So all the values in here now will be positive because cos is positive right round this value is positive right round this range here. So they're all going to be positive, and they're going to increase from 0 up to 1, up to minus 1 for cos, that is, which will be 4. So it's going to hit here at 4. So it's going to come round and increase all the while and go to 4. So that's what we've got then. Good. Now that's essentially the shape. Not drawn particularly well. So now the other thing to notice is that we've gone from 0 round to pi as an angle and drawn this shape here. But the nice thing about cosine is that if you went from 0 to minus pi and did the other half, these values of the cosine will be identical. So you'll get the same curve generated on the other side, the mirror image on the other side. Are you happy with that? That's the cosine has the same values here, 0 to pi, as it does from 0 to minus pi. So these values of r will be the same in these coordinate quadrants as they were in these quadrants. So that results in the same mirror image being generated. So we'll basically be drawing a curve like so, and then round to 4. Sorry it's not drawn terribly well, but let's just confirm that then with the plotter. We got a little My A-Level Maths Tutor plotter here that I've written, a little widget. So I just pop that up. And we need to type in 1 minus 3 cos theta, don't we? So let's get rid of that one then. That's already there by default. 1 minus 3 cos theta. R equals 1 minus 3 cos theta then. Between 0 and 2 pi. Let's see if we were on the right tracks. Yeah, there we go. You see what happened? From 0 it was here. And then when we went round to about here, when cos theta was a third, we went round from here to here, all negative, and then it went to 0. Then after cos theta was a third, to pi over 2, they were all positive, and they went to 1 at pi over 2. And then since the cosines were all negative here, the 1 minus 3 cos were all positive. And then the biggest one happens, cos goes from the value 0 to minus 1, so that biggest value would have been 1 minus 3 cos, 1 minus 3 times minus 1, which is 4. And then you can draw the other side here is identical that you drew. So you just do the mirror image in the other two quadrants. Using the property of the cosine, and that is that the fact that cosine x is equal to cosine minus x. It's an even function. But that's just an observation to help us do half the work. Okay, then I know I've dragged it out, but next question we'll do a bit more briefly.